Hello everyone. Today we are going to go over how to solve an equation with one variable for Algebra 1. So in this video, we'll look at equations with one variable and what steps we can take to isolate that variable and then find out what values work. Okay, so to start off, we will take a look at what it means to solve an equation. So solving an equation means to find all values of the variable that we're solving for. We're just going to call our variable x in this video. All values of x that make the equation true. So for example, if we know that x plus 2 equals 5, so the only value of x that makes this true would be 3. We know that 3 plus 2 gives us 5. So x is 3, and we just solved that equation. So solving is finding all values of x that make the equation true. In other words, we want to get the variable by itself. And you might hear me refer to this as isolating the variable. So we want to isolate it, get it by itself on one side of the equation. And that way, as you can see here, we have x by itself on one side. We can see exactly what it's equal to. Okay, one quick definition I want to go over is the word term. A term in an equation is each part. In other words, we have numbers / variables separated by addition or subtraction. So all of the different parts separated by addition and subtraction. In our previous example, we had x plus 2 equals 5. X is a term, 2 is a term, and then on the other side we have one term, which is 5. So we have 3 terms in this equation. So when we talk about working with terms, we're talking about the different pieces separated by addition and subtraction on both sides of the equation. Okay, so when we're solving an equation, we can do this by undoing all of the things that have been done to our variable. So we want to undo operations for x that were done on x. An equation is a statement that says that both sides are equal. So when we have an equal sign, it's saying that both sides are equal. What this means is that if we do something to one side, we can do it to the exact same thing to the other side, and the statement remains true. So both sides are still equal. If I'm weighing something and I have 5 pounds of coins, for example, and 5 pounds of eggs, if I add 5 pounds to both sides, then the statement remains true. They still weigh the same amount. So we can perform operations. We can add, subtract, multiply, divide, and as long as we do that to both sides, then our equation is true. So we haven't changed anything, and we can work from there. So what we can do is move terms around by adding or subtracting those terms. An example is if we have x plus 2 equals 5. So before we just figured out, all right, x has to be 3, because if we add 2 to 3, we get 5. We can also isolate x or get x by itself by looking at this 2. So on this side, on the left side, we have x, but we've added a 2 to x. So in order to undo this addition, we need to subtract 2. And because we're subtracting 2 from the left side, we need to subtract 2 from the right side also. So x equals 5 minus 2, and then x equals 3. So we ended up with the same answer, and we did that by undoing that addition that we had on the left side with x. Okay, when we are undoing operations, what we want to do is first get all terms with x on one side. So sometimes you'll have x on both sides of the equation. You want to move them over so that they are on the same side of the equation. An example of this is if we have x is equal to 5 minus 4x. So notice we have x on both sides of this equation. the first thing we want to do is make sure we get x on the same side, all of the x's. So here we're subtracting a 4x. So to move this 4x to the other side, what we can do is undo the subtraction. We can add 4x. And because we're adding 4x to the right side, we have to add it to the left side also. Okay, so we end up with x plus 4x equals 5. So we're good. We got both of our x's on the same side. This is helpful because when our x's are together on the same side, then we can then combine like terms. Combining like terms means we add or subtract the coefficient, which is just the number that we have in front of the x. So whatever number is in front of x, we can add or subtract the coefficients of the terms that have the same variable raised to the same power. So as long as it's x to the first power, then we're good for both of these. So on the left side, notice we have x plus 4x. We can add these coefficients. If we have no coefficient, it just means we have 1 in front to get 5x. So on the left side, we now have 5x. Oops. 5x equals 5. Okay, so we got our x's on the same side. We added or combined like terms by adding the coefficients. We also want to get anything that's not x on another side. We call any terms that are just numbers, like 5 or 10, constants. So get constants on the other side. In this case, our constants are already on the other side. We have one constant, 5, on the right side. Sometimes you'll need to move them over like we did previously up here. Notice we had x and we had 2, and we subtracted 2 from both sides to get all of our numbers or constants on the right side. So our third step is to get constants on one side. Okay, so we want to get the variable on one side, get constants on one side, and then we want to combine like terms, add and subtract. Finally, we need to undo any remaining operations. And this usually means multiplying or dividing on x. So if we take a look at the example that we've been going through, we had 5x equals 5. Notice that we are multiplying x by 5. So in order to get x by itself or isolate x, we want to undo this multiplication. To undo multiplication, we need to do the opposite of multiplication, which is division. So we want to divide both sides by 5 in order to undo the multiplying by 5. So if we look at our equation on the left side, 5 divided by 5 is 1. So we have 5 divided by 5 times x, which is just 1. And then on the right side, we have 5 divided by 5, which also gives us 1. So in this case, x now has nothing's being done to x. It's not being multiplied or added to. It's isolated. And we have one number on the right side. We have our solution. So x is equal to 1 for this equation. And the original equation we had was x equals 5 minus 4x. So we added, subtracted, and divided both sides in order to end up with x by itself, finding our solution. Okay. One final note is sometimes we'll end up with an equation that doesn't have a variable. If we end up with something, in other words, an equation that is always true, for example, if we had 3x plus 2 equals 3x plus 2, notice we could start off by subtracting 3x from both sides. We're trying to get the 3x's, or sorry, all of the x's on one side. 3x minus 3x plus 2 equals 2. And then 3x minus 3x, if we take 3 and subtract 3, we end up with 0, so 0 x's. We get a statement 2 equals 2. And this is always true. So this is always true. that means that we have infinite solutions. So any number that we put in for x will make the equation true. So infinite solutions is our answer in this case. On the other hand, sometimes we'll end up with statements that are never true. If a statement is never true, then we have no solution. So no value of x is going to make that statement true. An example would be if we had x plus 4 equals x. So in this case, we could start off by subtracting x from both sides. So x minus x plus 4 equals, on the right side, we end up with 0. And then we see, if we do x minus x, we get 0. We have 4 equals 0. And this statement, 4 equals 0, is never true. 4 is never equal to 0. So in this case, we have no solutions. So if you ever notice that our variable is gone, you want to look at our equation and see, does this make sense? Is this true? Or is this not true? Is this not working out? Okay, so that's how we can solve equations and the steps we can take to solve equations when we have one variable in an equation.